Hello and welcome. So the article that we're going to be talking about today is about an in vitro left heart model. So here is a left heart. Here is the left atrium. There is the left ventricle over here, and in between them we have this mitral valve, which it will with its leaflets. And inside the left ventricle, the mitral valve leaflets is connected to papillary muscles. And when the mitral valve leaflets shut, the papillary muscles get tensed, and a tension builds inside it. So physiologically, how does the mitral valve closes? Usually, is it happens in systole when the left ventricular the pressure inside the left ventricle um, increases, and so that creates the mitral valve, and that shuts the mitral valve and prevents mitral regurg. So if we want to do some experiments on the subvalvular apparatus, uh, if we create if we create the normal physiologic if you simulate the physiologic responses, um, the pressure inside the ventricle is going to be high, as we've said, and this is going to restrict the access to our instrument to measure these physiological changes. So one thing the researchers have thought of to solve this issue is by actually creating a negative pressure inside the left atrium by using a vacuum, and this will shut the mitral valve leaflets, and it's gonna keep the left ventricular pressure in its 0 atmospheric pressure, and then we're gonna have this instrumental axis. So usually, as we've said, the physiologic transvalvular pressure is it's 120 millimeter mercury and 0 here in the left atrium. But again, the researchers here is gonna reverse these measurements. They're gonna create a minus 120 uh, mercury pressure in the left atrium, and it's gonna be 0 pressure in the left ventricle. As you can see here, when the vac turned on, the left atrium fluid get pulled and it increases. The level goes up, and the valves close, which gonna prevent mitral regurg, and the papillary muscles are gonna get pulled and tensed, and that's gonna create a measurement on this scale, so we can know and measure how much tense in newtons is the papillary muscles facing. And also by doing this, we can measure and see if there is actually mitral regurg is happening in this in vitro heart, because this fluid level is supposed to be constant. If it goes up, that means that mitral regurg is going on. And by the way, so there is an important point that I did not mention, which is, so all of this parts of the model over here, they're synthetic, made of plastic, but the muscles here are they are brought from a pig, so they mimic the normal physiology. And they measured the pressure, and it was about 4 newtons um, in this experiment. So okay, so thank you so much for watching.